Hello and happy Monday. Exam 3 is this week on Thursday. This exam is going to be on D2L and there will be a study guide posted by the end of the day. In this chapter, we are going to keep things simple and just focus on meats and break down the exciting science of what happens to meat when it is cooked. A good portion of this chapter will be broken down into getting meat to taste good. So first, we will start by reviewing what good meat is, and then we will look at what we can do in the kitchen to make sure that the meat that we cook is of a great quality. The rest of this chapter will talk more about what we can do to keep meat safe, and a lot of this information is going to seem like simple review, but please pay careful attention to this section and to this information because it is very easy to contaminate meat, and contaminated meat is highly dangerous. And then we will finish by spending 1 or 2 slides just on health considerations and nutrition facts about meat. We're keeping the learning goals simple for this chapter. It's very important that you understand the concept of tenderness. So tenderness is the most ideal characteristics of meat, and it is the main goal of cooking meat. So know how we can achieve optimal tenderness from meats and know its relationship to connective tissue. Also, again, the food safety is incredibly important to meat because meat is very, very susceptible to foodborne illness. So know the temperatures that we have to cook different types of meat to. Know the temperatures for refrigeration and why this is important. And then know the associated risks for food that occur due to pathogens being present in meat. We're going to start this chapter off by defining what meat is and then explaining what it is not. And then we're also going to review the ideal characteristics of meat. So if we are going to eat meat, under which circumstances will it taste best? What is it that we can do to make sure that the meat that we eat is of a very high quality? And with this entire section, we're really going to be focusing on how we can create optimal tenderness in our meat. First and foremost, any animals that are birds or fish are not considered meat. So birds are any type of poultry, things like chicken and turkey, and then fish is pretty self-explanatory. A lot of the same principles that we do talk about in this chapter can apply to birds and fish, but when we talk about meat, we are talking about anything other than birds or fish, and meat is going to be the flesh of animals that is used for food. So we have beef, which comes from cows or cattle. We have pork, which comes from pigs. Veal is beef from young cows. We'll talk a little bit more about what makes veal so special later on in this chapter. And then lamb is another form of meat. Meat composition is pretty self-explanatory, but there's one concept I'd like to highlight in this slide. Meat consists of bone, it consists of fatty tissue, it has muscle, connective tissue, and there's also pigments that are going to give meat its specific color. But let's take a closer look at muscle and connective tissue because these are related to tenderness. Muscle and organs are all going to be surrounded and encased by a thing called connective tissue. Again, connective tissue is tissue that surrounds and holds in place muscles and other organs, otherwise known as tendons and ligaments. So meats that have more muscle are going to have more connective tissue because you need more connective tissue to surround that muscle. Also, older animals, as they age, they develop more and more connective tissue, so their meats are going to be tougher as well. And so in the picture on the left, you can see a muscle fiber, and that surrounding layer is all connective tissue. If you look at the picture on the right, all of the pictures closer to the bottom and closer to the right, they have more white pieces in the center of the meat. Those white pieces are connective tissue. And we're going to talk about why that's important in future slides. Above anything else, meat needs to be tender and it needs to be flavorful and juicy. Tenderness, that describes the ability of the meat to crumble or fall apart in the mouth. So if we take a bite into the meat and it's really tough and we have to really pull with our teeth to tear that meat apart, that meat is not tender, it's very rough. We want meat that when we bite into it, it may not come off right away, but it's going to come off relatively easily. And meats that are more tender have less muscle and therefore less connective tissue. Or if they do have a lot of connective tissue, we would have to break it down at some point during the cooking process. And the flavor of meats is very complex. It actually involves a combination of all of the main tastes. But it's very important that meat, in addition to having all of these tastes and this specific but complex flavor, it also should retain quite a bit of water or juice from the meat. Veal is a very tender meat that is used from very young cows. Now these cows are not exercised, and this is done intentionally to prevent muscle development. Less muscle means less connective tissue, which means that these meats are going to be very tender naturally. This picture on the bottom of this screen shows a piece of veal. Look at the amount of pink meat compared to the amount of white connective tissue on the meat. Again, the white represents the amount of connective tissue. So this should tell you, because you can see such a low amount of it, that this meat product is going to be very, very tender. So let's review what we know so far. Number one, tenderness is a good thing when it comes to meat. Number two, connective tissue in meat means that meat is going to be less tender. So knowing those two things, we can still work to create an optimal tenderness. So we have to adjust the tenderness through the connective tissue, and this next section is going to discuss how that is done. So there's a few specific methods. We can do long, slow cooking. We can increase the fat content of the meat. We can also age the meat, and then we can also tenderize the meat. And we'll focus on some of these over the next few slides. There are two main processes that occur when we heat or cook meat. The first one is very obvious, and we've discussed this before when we talked about eggs. This is coagulation. Proteins, regardless of their source, will coagulate. So the meat, when this occurs, the meat is toughened or made more solid. If you consider what happens to eggs when we cook eggs, you see quite a bit of solidification of those eggs. The coagulation that occurs with meat is not quite as drastic as what occurs with the coagulation of the eggs, but this is still the same process. Longer, slower heating is going to break down more connective tissue, and the key concept for heating meat to create a more tender meat is time. So notice that we're talking about longer periods of heating at lower temperatures. Exposing the heat for a longer period of time, regardless of the fact that it's lower, is going to break down more connective tissue than if we were to cook meat at very high temperatures for a short amount of time. So again, the longer that the meat is heated for, the more the connective tissue can be broken down. Here's an extra credit question. For 2 points, can lean meat become tender? And if so, how can we increase the tenderness of a meat? These points will be added to your most recent exam. If you think that you know the answer to this, please send me an email and I will update that as soon as possible. Increasing meat tenderness can be as simple as pounding meat with a hammer. Well, it's a bit more complex than this, but that's the basic concept. If we take a tenderizing mallet, which is very much like a hammer, as you can see in the picture on the screen, and pound the meat, that's going to help break down the connective tissue in that meat. Now note that on this mallet there are also little needles, and these needles will go into the meat, they'll dig in, and they'll break apart some of that connective tissue as well. But it's a very simple process. We're simply just pounding the meat. In addition to heating meat at low temperatures for a long period of time, and then pounding the meat with a meat tenderizer, there are certain chemicals that we can add to meats as well that are going to cause the connective tissue to break down and to become more tender. So the main three chemicals are enzymes, acids, and then dairy. And enzymes, they are added from certain foods, and they're going to increase the rate of certain chemical reactions that occur within the meat that cause the connective tissue in the meat to be broken down more quickly. Now, acids such as lemon juice or vinegar are frequently added to the meats as well before they are cooked, and these are going to also break down the bonds of collagen surrounding some of the tougher proteins. For dairy, buttermilk and yogurt are commonly used to tenderize meats. These two foods have low levels of acidity, but they also contain calcium. And this calcium is going to activate an enzyme in meats that will help to break down its connective tissue. Meat is incredibly susceptible to foodborne illness. So it is essential to handle meat appropriately, to cook it to the right temperatures, and store it at the correct temperatures when we are not using it. There are specific foodborne microorganisms found primarily in meat and meat products that pose an exceptionally high risk for disease and for severe health complications. We will outline one of these, explain its consequences, and then list a few ways to effectively kill these microorganisms and prevent them from reaching unsafe levels. There are certain ways to handle and store the food that we are going to review as well. So specifically, we will be looking at cooking, pre-cooking, and preventing cross-contamination, and then also refrigeration. Also, all meats are not created equally, and some pose greater risks for microorganism contamination than others. We will talk more about what these are in this chapter as well. There are a few foodborne illnesses that are associated with the intake of meat, but E. coli is one, if not the, most prevalent cause of foodborne illness. E. coli is commonly found in beef. We can eat a food that contains very high levels of E. coli, but it may take days to a week before we actually start to experience the symptoms of this illness. So it's very difficult to trace back E. coli to its food source because it shows up so long after we've eaten a food that is contaminated with E. coli. E. coli is going to cause mainly digestive related complications, and these are pretty severe digestion complications. So there's a significant amount of abdominal pain and a very severe diarrhea. In people that have compromised immune systems, including young children and older adults, this disease may lead to more severe complications, including death. By following the following food safety guidelines, we prevent this when we cook meats. Notice how beef, veal, and lamb steaks and roast only need to be heated to 145 degrees Fahrenheit, but when you cook them in their ground versions, they need to be heated 15 degrees warmer. Now think about this for 1 second. Why might this be? Why are ground meat products Why are they at a higher risk for foodborne illness, and why do they need to be cooked to higher temperatures? All of this is related to surface area. So if you think about ground beef, there's a lot more area of that ground beef that can be contaminated, and it can come into contact with microorganisms. So because it has a much greater surface area, it needs to be cooked to higher temperatures. The last food safety concept that we're going to talk about is cross-contamination. And this is something that we need to prevent when handling meats specifically. So there's a lot of very dangerous microorganisms present on the surface of raw meats that are going to be killed when they're heated. So we cannot let uncooked meat come into contact with ready-to-eat foods of any kind at any point. Even something as simple as using the same cutting board that has come into contact with raw meat for cutting vegetables can transfer the microorganisms from the raw meat, from the juices of the raw meat that come onto the cutting board, onto the raw vegetables. So say we're cooking a chicken salad, we chop up the chicken into multiple pieces, we put the chicken on the stove, we cook the chicken, but then use that same cutting board for celery and then the onions. If we have not washed it appropriately, if we have not washed the cutting board appropriately, the microorganisms from the juice of the meat can come into contact with those vegetables, and then when we eat those vegetables, unless we actually do cook those to very high temperatures, they are going to carry those microorganisms and can cause foodborne illness in us. There has been a lot of research that has suggested that meat is related to cancer, heart disease, and the development of a variety of other long-term chronic health conditions. Now, we've researched this further, and the most recent research that we have available to us says that these health conditions are largely related to the intake of processed meats. So processed meats, they pose the strongest link to inflammation, which therefore is related to these specific chronic long-term diseases. Now, unprocessed meats, they contain nutrients that reduce inflammation, and they also decrease the risk for these types of chronic long-term diseases. That's it for this chapter. Again, you have your exam this Thursday, and that exam will be on D2L, available all day long. It will be available to you when you start taking it for 1 hour, and it will be in the exact same format as our previous exams. There will be a study guide posted by tonight, and if you have any questions, please send me an email and I will get back to you as soon as possible. Thank you all and have a great week.